Good day, viewers. You are welcome. How to solve this algebra problem, Math Olympiad. If we have x plus 1 to the power of 4 minus, open bracket, x plus 5 to the power of 4 equals 65. To start with solving this problem, here which is x plus 5, we start the problem from here. So by letting this x plus 5 equals a, which is x plus 5, and what I need here is I want to derive x plus 4, but what I have here is x plus 5. It means I'm going to subtract 1 from both sides. So when I subtract 1 from both sides, we have this as a minus 1 equals x plus 4. That is, anywhere I see x plus 4 here, I'm going to replace it with a minus 1 and x plus 5 with ordinary a. So therefore we have a minus 1 to the power of 4 minus a to the power of 4 equals 65. Then we have a minus 1 to the power of 4. We are going to expand this by considering the Pascal triangle coefficient. So for this expansion of a minus 1 to the power of 4, and we recall the coefficient of it, so by triangle coefficient, which are 1, 4, 6, 4, 1. All these are the coefficient of the 5 terms we are going to get when we expand this. And the expansion of this is a to the power of 4 minus a to the power of 3 plus a to the power of 2 minus a, and we have plus 1. So here is the expansion of this without the coefficient. But when we introduce the coefficient to it, what we have is a to the power of 4 minus 4a to the power of 3 plus 6a to the power of 2 minus 4a plus 1. And with this we have minus a to the power of 4 equals 65. So here a to the power of 4 cancel a to the power of 4, and we are left with minus 4a cube and this. So here is negative, which starts this equation. If I open this with negative, or let's say I multiply 2 negative, what we have here is 4a to the power of 3 minus 6a to the power of 2 plus 4a minus 1 equals minus 65. And we transfer this negative 65 to this side, and we are going to have 4a to the power of 3 minus 6a to the power of 2 plus 4a, and when this come here it becomes plus, then minus 1 plus 65, that gives plus 64, then equals 0. So looking at this as well, we can divide everything by 2 to reduce the highest of this coefficient. So dividing both sides by 2, we have this as 2a to the power of 3 minus 3a to the power of 2 plus 2a plus 32 equals 0. So here is a cubic equations. We are going to solve this for all the values of a, and by inspection method, so we know that, let's say I substitute a equals minus 2 to this. So substituting a equals minus 2 in this, we are going to have 2 bracket minus 2 to the power of 3 minus 3 bracket minus 2 to the power of 2 plus 2 bracket minus 2 plus 32. So everything equals 0. So here we have minus 2 to the power 3, which gives minus 8. And 2 multiplied by minus 8 is minus 16. Here minus 2 to the power of 2 is 4. So minus 3 multiplied by 4, that is minus 12. And here we have minus 4 plus 32 equals 0. So the whole of this one is minus 32. So minus 32 plus 32, everything equals 0, which means that at a equals minus 2, it satisfies this problem. So therefore, we have already one solution from this cubic equation, which is a equals minus 2. So the next thing is we are going to obtain the other roots. And what we are going to use here is synthetic divisions. So from here we have a cube, a square, a, and constant values. Let's take out all of their coefficients. So by taking out their coefficients, we have 2. Here is minus 3, 2, and 32, which we have one of the solution here, which is at a equals minus 2. So here is the trick. So the first term here, which is a to the power of 3, so it doesn't have anything. We are going to rewrite it as 2. So the next one is we multiply this minus 2 by 2. Minus 2 multiplied by 2, that is minus 4. Then minus 4 minus 3, it gives minus 7. Then we multiply this minus 2 with minus 7, which gives 14. And this plus this, that is 16. So minus 2 multiplied by 16, that is minus 32. Then addition of this is 0. As soon as we got 0 here, so we are good to go. So why the non-zero values that we got? So it is 3 times, which means it is a quadratic equations. So here we are going to introduce back our variable, which is a. So therefore we have this as 2a squared minus 7a plus 16 equals 0. And to solve for the value of a here, when we consider from these quadratic equations, let's say we apply the completing the square method. So what we do first is we transfer this one to the other side and we divide both sides by 2. So we have x squared minus 7a over 2, everything equals minus 8. And with these two sides, I'm going to multiply this one by half and take the square of it, then add it to both sides. So here we have a squared minus 7a over 2. So here is plus. We have this as 7 divided by 2, all to the power of 2. And alright, so here should be 4 equals, and here we have minus 8 plus 7 divided by 4, all to the power of 2. So when we combine this and this together, what we are going to have here is a minus 7 over 4 all to the power of 2 equals, so with this we have 7 square, which is 49, and 4 square, which is 16. So we have minus 8 plus 49 divided by 16. And when we multiply 16 by minus 8 and we add it with this, so what we are going to have is, here is a minus 7 divided by 4 all square equals, so let's multiply this and this together. Minus 8 multiplied by 16, we have 16 multiplied by 8. So 8 multiplied by 6, that is 48. We have 8 carry 4. So this multiplied by this, that is 8 plus this, that is 12. We have this as minus 128 because of this negative. And when we add 49 with this with this one. So let's do that. Plus 49. So which means we are taking out this 49 from here. So taking out this is not possible. So what we do is we lend 1 from here, and when we take out this, we get 9, and the remainder of this is 7, which means we have minus 79. So we have minus 79 divided by 16. So the next thing is we take the square root of both sides. So doing that, we have a minus 7 over 4 equals plus or minus the square root of minus 79 divided by square root of 16. And we take this one to the other side. Here is a 7 over 4 plus or minus. So here we have minus in the root, which gives I root 79 divided by, and square root of 16, that is 4. So the result of this is a, which is 7 plus or minus I root 79 divided by 4, which gives the complex solutions. And we have a, which is minus 2, but what we need is x. So we are going to record from here, which is a equals x plus 5, and at a equals minus 2, which is the real root, so we substitute here, which is minus a equals x plus 5, and we transfer here, which is here is minus 2, so we transfer this, which is minus 2 minus 5 equals x, and we get x equals minus 7, which is the solution to this problem. So here is how to do this. Thanks for watching, and please don't forget to subscribe to this channel for more exciting math content like this. I will see you in the next video. Never stop learning. Bye bye.